All right, good morning, everybody. I want to welcome you to our NCAP from Research to Implementation webinar series. I'm really excited about this month's installment on thick lift asphalt paving. It's something there's a lot of questions about that are out there, and a few states have really taken this and gone with it, and we would love to see other states take it on. So, as always, we have Nathan Moore with us today, and then we have Kimmy Lyons from South Carolina DOT, and we have Jay Thompson, who used to be with South Carolina DOT, and he works with IEC at this point. So Nathan is the Assistant Director for the Test Track Research at the National Center for Asphalt Technology. He's responsible for overseeing all of the test track research programs. Prior to this role, Nathan had served as a lab engineer. He'd been there for about 8 years at NCAP. Specialized in balance mix design and friction of pavements. He holds a bachelor's and a master's degree from Auburn University in civil engineering. He's licensed in Alabama. He is working on his PhD as well. About got that wrapped up, but he's always running the kids as well. So he's got that going for him. Kimberly Lyons is the asphalt materials engineer for South Carolina Department of Transportation, where she previously served as the state reclamation engineer. Prior to being with South Carolina DOT, Dr. Lyons served as the technical director for the South Carolina Asphalt Paving Association. She's a graduate of Clemson University, where she earned her bachelor's, master, and doctorate with civil engineering, and had an emphasis in geotechnical engineering and construction materials. And she's a lot of fun. We really enjoy having her on the Capri and the things that she does there. Jay Thompson is a former state pavement design engineer for South Carolina DOT. He's been involved in the fields of pavement engineering and construction engineering inspection for 24 years. He's currently employed by the Infrastructure Consulting and Engineering. He's their vice president for pavement consultancy services, operating all around the southeastern United States. His role at ICE is focused on pavement design and management, along with support for construction projects through problem solving and value engineering. We're really excited to have these two on here. They've been involved with thick lift paving since we first started doing research on that. So we're glad to have them here. I do want to remind you, please keep yourself muted when during this presentations that we have here today. We always like to answer the questions at the end, so please put your questions in the chat box. I'll kick that up in just a minute. Given that, Nathan, will you take it away?
Bang. All right, everybody. Travis, you see my slides good? Everything
Yes,
look good?
yes, sir.
Excellent. All right. Most of you who are, have been part of this research implementation series, you know how this goes. But for anyone who's new, Travis has already done an introduction. I'm going to briefly introduce this topic, but really I want to make sure that I give Travis and Kimmy and Jay as much time as possible, and then we'll have time at the end for questions. So Travis is going to give some instructions in the chat, but if you have questions, don't feel like you have to wait to the end. Go ahead and utilize the chat in Zoom. Write those questions out. If they're simple, we'll respond to them. If maybe if they need some feedback, we'll get to them at the end. But we love to have that kind of interaction as we go. So please get the questions going. So I'm just going to go over a brief history of thick lift paving at NCAT. We started this in 2018 with South Carolina DOT. And so they deserve a lot of credit for coming to us and saying, like, look, hey, we've started trying thick lift paving with the goal being a rapid rebuild of shorter sections, but that we can do in a single lane closure. So you've got they broke a lot of the sort of the groupthink and the rules of thumb, and they said, let's try something different. And the goal of saving a lot of money, and especially for their road users in South Carolina. Well, we learned a lot from this, and Travis is actually going to talk way more about it. But in 2021, when we rebuilt new test sections, we took the work that we did with South Carolina, and we said, look, if we can build single lift test sections. And so we actually constructed all of the additive group sections in 2021. In total, we ended up doing about 7 or 8 of these. to 5.5 inches thick in a single lift. And so when you do that, you limit potential for poor bond or delamination or so it was an excellent technology that we learned with South Carolina, and then we said, hey, we can do this ourselves, and we've continued this practice even into the test sections in 2024. I'm going to just briefly skip to the end and talk about lessons learned, but then I'm going to let Travis and Kimmy and Jay talk more about this. If this picture doesn't sort of make it clear, smoothness can be challenging. However, on the NCAT test track, we have the added challenge that our test sections are 200 feet. I think that the folks over in South Carolina have figured out how to do this really well. But smoothness can be an issue because you really only have one shot at it. Warmix asphalt is your friend. It helps with compactability. If you're trying to compact 6, 8, whatever inches of asphalt, that's a lot of material that you're trying to move, and any compactive effort aid that you have is helpful. And joint density is also important. You really only get one shot to seal up that joint. You don't have extra layers, sort of to have multiple opportunities to seal up that joint. So joint density is really important, and I'm pretty sure that Travis and our friends from South Carolina are going to talk about that. With that, I try to make my point as short as possible because I'd really like to hear what our presenters have to say. So Travis, I'm going to quit sharing and kick it over to you.
So this is something I'm really excited about. It's not the first time we've done thick lift paving on our implementation webinar series. In fact, our very first one about 3.5 years ago was thick lift paving and the work that South Carolina has been doing. So what do we see here? A road that absolutely needs rebuilt. It's probably failed all the way through. And if we look down that road, we can see that that is a problem. So I really want to answer this question is, well, how can we reconstruct our full depth asphalt pavements in less time? How can we be less impacting our traveling public, less time to have our contractors and our inspectors out there in the traffic? And so one of the answers that is out there, things that we're doing is thick. Let's pave thick. And when we say thick, how much are we talking, right? So a lot of specifications out there have a minimum thickness. Some of them also have a maximum thickness. I was just looking at one yesterday morning with a state that's got some questions about thick lift paving, and their specification has a limit of a 3-inch maximum lift thickness for all of their mixes. So that's kind of a change that they would need to make if they wanted to use this kind of technology. But I like to say that thick lift paving starts around 5 times the nominal maximum aggregate size and goes up from there. And NCAT has done some work paving as thick as 16 times the nominal maximum aggregate size, still get density, and still have a good, solid quality pavement. So what are our concerns, right? What concerns do we have if we're going to do thick lift paving? And that first one is density. That is the concern all the time. That's, I think, what we all came up in the asphalt industry understanding is that the thicker we go, the more problems we're going to have with density. And through the research that has happened at NCAT, the experience that South Carolina has, and then I'm going to share some information from Utah as well. We have found that density is actually easier to achieve with a thicker lift pavement. I've also seen some research that was done in Florida and Texas and other states that back that up, that's saying that thicker lift actually does give us a better opportunity for density. So other things that are a concern is things like temperature. With this thick mat of material that's out there, it takes much longer for that to cool down. So that mat stays hotter longer, which actually helps us with the density. It gives us more time to get that density, more time for that compaction, or the time available for compaction, the TAC that we teach about. Another thing people are concerned about is rutting. And we're finding that there's the states that are using this on a frequent basis have found ways to make sure that they mitigate rutting and that they don't have concerns. So I'm going to talk some about their mix designs and the things that they've done to try to prevent that. So keeping the paver moving, we're putting so much material down that there's some really critical keys here on how we make sure that we keep that paver moving we teach about that all the time. We talk about all the time. Don't let the paver stop. Let's keep the paver moving. Gives us a smoother ride, because smoothness really is a big concern with these thick lift pavements. I'm going to show you some pictures that none of us would be happy with riding on, but that really is that the smoothness is so important with thick lift paving. But that comes back to that operation. Permeability, again, like Nathan just mentioned, those longitudinal joints, we got one chance to get that in there. And there's some innovative technology on ways that we think that we can help mitigate that. But in the traditional way of doing these thick lift pavements, we have one opportunity to make that happen. Some concern is about roll down. Are we still using our 1/4 inch per inch roll down that we traditionally have? And I strongly recommend a test section. Do a test section, even if it's in the plant lot somewhere. Do a test section. Make sure we understand how that mix is going to compact down, so that we make sure when we're putting this out there on our roadway that we really know how far it's going to go. And then that paver speed, we're not going to go 35 foot a minute. We're just not. And so that's kind of a something that our crews need to work with. They typically want to go a bit quicker, but with that massive amount of material we're putting down in a single pass, the paver's got to move much slower. Plus, our trucking and hauling distances are going to have an effect on how fast we can move that paver. So I kind of want to cover a few things here. Some of the research that NCAT has done. I also want to talk about a couple states that have really taken this forward. And then I want to talk about some of the specifications and the changes that states have made that have helped them be successful with this thick lift paving, and a few keys to success. So NCAT's research started, like Nathan mentioned here, it started in 2018 when South Carolina DOT came to NCAT and said, hey, we want to try this. We think it's something that can help us and move this forward. So the first bit of thick lift paving that was done on with the NCAT test track was actually a test section off the track to try to make sure that this could be constructed. So we have this S9 test pass or test section that was done off to the side of the track to make sure that was something that could be utilized. So during that cycle in 2018, there were actually 3 sections that were built. So N10, N11, and N9. All of them performed fantastically. They're really happy with the results that we found there. And so with S9, they decided to continue the traffic into the next section. So that ran clear into 2024. And then, as Nathan has said, they're still doing some deep rebuilds on the test track during construction, and they're utilizing this technology that South Carolina sponsored and helped move forward with the track. So again, we talked about some of those concerns, right? So density, smoothness, and temperature. Those are the 3 big things that I want to kind of talk about here with the concerns that we may have. With density, first thing that we always hear, and it's what we were all taught, is you cannot get density when you pave this thick. And I really like the videos that Utah DOT puts out. Here's our good friend Howard Anderson, who does promote this. He's doing a wonderful job of promoting the technology and the things that they're doing there in Utah. But he says, yes, you can. We do it all the time. So they are able to achieve that density. If we look at the NCAT test track sections, these sections, after they were put in and compacted, we pulled density cores out of those mats and they cut them into thirds, so we could look at the top third, the middle third, and the bottom third. So this graph that we see here, we can see that S9T is the test section that was done off the track, and you can see every single segment of that was above 95% of the theoretical maximum density. So they were definitely able to achieve that. They dipped a little bit on the N11 section with the lower third there. You can see that dropped down below 92, but we've certainly learned where that is, and we're seeing that the states that are putting this in practice are getting extremely consistent results with achieving density above their targets with this thick lift paving. So smoothness, as I mentioned, smoothness is a concern, and you can see some ripples in this here. This is on the NCAT test track. You can see there's a few ripples there. Everything that we do for best practices is amplified when we do thick lift paving. So stopping the paver, adjusting the angle of attack, moving in gates in and out, all of those things, the defects that they make in the mat are amplified when we're putting the material down this thick. Here's one that's out on an actual roadway done with thick lift, and you can see that it almost looks washboardy, like we were running the vibratory roller too fast, but that's not the case. This is thick lift paving. They were starting and stopping the paver a bit and ended up with what's not going to be an acceptable ride. So we do need to keep that in mind as we implement and do this thick lift paving. Is, can we achieve the normal smoothness that we would with a standard paving project? Probably not. So we need to consider, are we going to allow diamond grinding to bring that back into the smoothness that's acceptable for our users? Or are we going to maybe come back in and do a thin overlay over the top to try to gain that smoothness back? But definitely something that we need to think about and consider as we implement thick lift paving. So the temperature in the mat with NCAT in the work that South Carolina helped us do back in 2018, they came up with this really, to me, a really ingenious way to check and see what the temperatures were doing through the depth of that mat. So they took this wooden dowel here and put the temperature probes. There's several of them there down through the mat, and after that mat was placed, before it was compacted, they inserted this dowel down into the pavement so they could monitor those temperatures as the pavement section cooled and was compacted. So they pushed a metal rod down in to create a hole, and then they pushed the dowel down in that had the temperature probes, kind of buried them up there, got them underneath so that we didn't tear them up, used with the rollers as we compacted the section. Carried that off to the side, and the temperatures can then be monitored. And so when the temperatures were monitored, we were really looking at, let's look at that top third, the middle third, and the bottom third again, and find what those temperatures did. So what we see in these graphs here is we see that top third is kind of that orange or red line. The middle is the gray, which is always on the top, if you'll notice. And then the blue is that second one down. And all of these things make a lot of sense to me, that the middle of that section is going to cool slower than the top and the bottom. We think about that. The ground, the subgrade material underneath is at ambient temperature, and that's going to be pulling the heat out of that mix. And across the top, we have a little bit of a breeze. We have the air, whatever the temperature is out there, far less than the 300 degrees that we put that asphalt down. So that end starts to cool. So it's really that center that kind of controls where we are with the temperatures. We can see these different test sections here, or the different times here on how that cools down. And it takes several hours. That's one of the things that we really need to consider, is that normally we have on say a normal 2-inch lift of material, we have 30 to 40 minutes, 45 minutes maybe, to get that density, to get from whatever the placement temperature is down to 170 degrees Fahrenheit. And with these projects here, we're seeing that it's taken 3, 4, 5 hours to get that temperature to be down to ambient temperature. So definitely something to think about when we're putting traffic back on the sections that were done with thick lift paving. So why look at thick lift paving? Why would this be important? So like Nathan mentioned, in South Carolina's going to probably tell us about, quicker construction times important. So if we have an application where we don't want that roadway or that area to be closed down for a long time, thick lift paving is a way that we can do a complete rebuild down to the subgrade in a much shorter duration. So I'm going to show you some photographs here in a moment. Utah DOT, their first one that they did here, they did it at a way station at a port of entry at the border, and they didn't want to have that out of service for a long time. We have heavy truck traffic, super slow moving because they're coming across the scales there. And so this allowed them to rebuild that section much quicker. Another motivation for using thick lift paving is we don't have an interface between multiple lifts. So we don't have concerns about are we getting bond as we put an intermediate lift and a surface lift back on top of our pavement there, because it's all being put down in one single lift. So it's definitely a consideration that others are using. We do have a longer time to achieve that density because these thick mats hold temperatures, and we saw that in the graphs on the last slide there, how this material holds that a whole lot longer. The layer interface issues, not just debonding, but Texas DOT did some research looking at the air voids that were at the interface between a surface lift and an intermediate lift there, and found that those surface voids, or that the voids around that interface there, were about 12%. They were able to get under 7, 6, 5% air voids, or get that 95% or so density in the middle of those mats when they were placed, but at the interface they were seeing about a 12% air void. So this is a way that we can eliminate that. And then scabbing, when we come back in to do a rehabilitation of this road later, that's always a concern we have. If we put in 2 inches, we're going to take off 2 inches. Are we really getting past that interface so that we're not having some scabbing issues and some delamination that comes up? If we're going thick like this, we could come back in after putting 8 inches down. We can come back in 15, 18, 20 years, however long that surface is going to last, pull down 2 inches and know we're not going to have any scabbing issues at that point. So we can also get this long-term life of the pavement out of these thick lift projects like that. And then density. Several agencies have been able to show and prove that it's easier to achieve density when they're paving thicker. So when it comes to the specifications for thick lift paving, some of the states that have really done some great work here, they're really modifying their mix designs. They're doing some things that kind of break the rules that we all live by with super pave mix design or Marshall mix design. And these things actually help their mixes become more compactable and work better with this thick lift paving. So I'm going to go through and show you what South Carolina, kind of what their mix design looks like, and I'm going to show you a little bit what Utah's mix design method looks like. But air voids we typically design to 4%. That's what Marshall did. That's what we do with super pave typically. There are some states that will drop that down, maybe 3.5 or so. But South Carolina is going to 2.5% air voids on their mix, and Utah, they started out around 1%, but right now their specification is 0.75% to 1.25% air voids, which for those of you that have been around mixed designs and done this for a long time, that's a scary place, right? We are always shooting for this 4%. So it's a scary thought to say we're going to have really low voids even in our design. Also some binder changes, right? Some of these states are putting a minimum binder content in here to make sure we don't get a dry mix, to make sure that we do have that asphalt binder when it's hot, acts as a lubricant, lets the particles slip past each other so we achieve the density that we want. So we need to make sure we have enough of that binder in the mix. And then the highly modified binders is another thing that we're finding that states are using to find success with these thick lift paving jobs. So to kind of highlight what Utah and Howard Anderson's doing right now with the things that they have out there, they're calling their mix design that they use for thick lift paving high mod. They use it for other things as well, but this is the mix that they use for their thick lift paving. Yeah, they call it their high performance mixture. It's used on interstates, high volume routes, overlays, rehabilitation. I don't know how many of you know, I grew up in Utah, so there's some routes that I drove a lot of times as a teenager that UDOT has been using this high mod thick lift on, and I'm really excited to go check those out when I get to visit back in the holidays here. They're using both a 1/2 inch and a 3/8 inch nominal maximum aggregate size here for their thick lift paving. They're going as thick as 8 inches with this. They are using a highly modified binder. This is a PG 76 minus 34. So we would typically call this like a HYMA binder in other things here. And but it's something that they require. They have a percentage range for their AC content with these mixes. They want to see somewhere between 6 and 6.8. That's written into their specification. Like I mentioned, their design air voids 3/4 to 1 1/4, and that's at a 50 gyration. So they're really working that mix design side to make sure that this mix is compactable. Utah is a hydrated lime state. They use hydrated lime in everything that they do to mitigate the stripping concerns that they have. They also require a warm mix additive on this. I can see that Tim Ashenbrenner asked about that, and definitely something that they use there in Utah. In fact, on that port of entry project that they did, I think they had over an hour, about an hour and 15 minutes or hour and a half haul time from the plant to the project. And so they do require warm mix when they use their high mod here. They do have a wrap option. You can put up to 15% wrap in that Utah mix. And then their target densities. I think this is really important here. Their mat density target is 96%. We see a lot of specifications that see the bottom end of that density range, you know, 92, 92 and a half, 93. These guys are targeting 96%, and they bracket that to try to make sure that they get the good density. And they're finding that they're achieving the densities that they want to. And then 94 on the longitudinal joint. So Utah has really paid attention and said, we only have the one chance. So we're going to make sure that we get a really good density on that joint. Most of the joint densities that we see in specifications are around 90%. Utah's using 94 at this point. So here's the port of entry over in Wendover. They did that thick lift paving on for their first project that they had done. One little fun fact about this is that the contractor, the day before the project, had done a test section in their yard at the plant. They did it in the midday or so. At 3 o'clock in the morning, they were very concerned because it was time to start production for the actual project, and they still hadn't cooled down to ambient temperature with their test section in their yard. But the project turned out really, really well. They've gone back and looked several years later here. They've seen pretty much no rutting, and it's really, really performing well. If you get a chance to see Howard's presentations on what they've done there, it's definitely worth your time to see what he's done. So temperature is a big deal here, right? We have that temperature that takes a while. So this graph is from some of the stuff that Utah has done, and we can see on the x-axis there is time in minutes. On the y-axis is the temperature. So we're starting out at about what's that? About 280 degrees or so. We see that quick drop off the bat, but because this thick mat holds so much temperature, we get out here to 3 hours, we're just now getting down to that temperature range of about 175 degrees, where we would consider that we're not going to get any more densification of the mat even if we roll it again. So definitely something to consider when we're doing these projects. We can get the process done quicker because we put it all down at once, but we need to watch that temperature before we release traffic. So here's some core results from the work that UDOT has done. As you can see, most all of those are well into that range of that 96 that they're looking for or above it. A couple of those are a little bit less. Their specification currently says that when we do a thick lift paving project, we're going to pull a core for density. We're going to cut the top 3 inches off, and we're going to check the density on the top 3 inches, and we're going to check the density on whatever that remainder is. So here they have their top half. You can see that all of those are above 97%. So, I have a lot of confidence that they've closed that off. They're going to make sure that they don't have any permeability problems here with having those voids interconnected. The bottom half, most of those look really good. A couple of those are a little bit different. But when we go back and look at this is 6 inches plus on this set of data that they have shared with us here on the amount of material that they're putting down, and still achieving those densities. And I know for so many of us that in the asphalt industry have found issues or concerns with that thick and been taught thick, when we go thick, we can't get density. Here's just another data point that shows us we absolutely can do that. They've really embraced this in Utah. They've put a whole bunch more projects out there. Here's a list that they shared with me of the projects that they were doing. In 2024, they put 500,000 tons of their high mod mix down. So they've really embraced this and moved forward with it in Utah. South Carolina, I don't want to take too much of what Jay and Kimmy are going to talk about. Their mix that they're using there is called their Type B intermediate mix, and it's used for rehabilitation repairs, interstates, high volume roadways, primary routes. I know they use it on some of their beach areas where they have tourism there. That's a big driver for the economy in that part of the state. And so if we can get in and fix that road and get back out of there, then we're not disrupting the tourism traffic. They're using a 1/2 inch nominal maximum aggregate size mix here. They're using a pretty standard PG64-22 binder, but they do allow a fairly significant wrap content there. They are using the warm mix as well to extend that time available to get the compaction in. They're running at cooler temperatures, so they're keeping their mixes down under 300 degrees Fahrenheit here. And like I mentioned, they run a 2.5% air voids here. They're running 75 gyrations on this, and then they have that on this example here, they have an asphalt binder content of 5.75%, and that's the breakdown of what the virgin and the wrap contribution to that binder content are. I got the chance to go visit one of their projects a while back. This is on an interstate, on Interstate 26, and you can see they have gone deep. This was 8 inches they milled out that night, and then they came back in and put 8 inches back in, got it compacted, and off they go. So really neat to see them embrace this technology and move forward with something that they researched with us at the NCAT test track and move forward into production. Some of the keys to success that we've learned from these agencies that are using this a whole bunch is that we need to adjust our mix design. We can't take that off the shelf mix design to make it work. We need to do something. Air voids is probably the thing that stands out the most. I do like also that they're using the warm mix in these. Balancing the operation is key here. Make sure that we have enough trucks to keep that paver moving, because every mistake we make is amplified with our thick lip paving. I guess that's the next bullet right there. Understand that every best practice is amplified when we do this. Smoothness is key. We need to use all those best practices, keep the paver moving. Don't be chasing the angle of attack out there. We may need to have in our contract the ability to come back in and diamond grind to get the smoothest we want, or put a thin overlay on to get the smoothness that we want. And communication is so important here, not just between the agency and the contractor, but the contractor's internal communication on trucks coming back and forth, keeping the trucks spaced out. All of those things become really, really important to be successful with these thick lift paving projects. So I do want to put a plug out there real quick. I've talked about 2 states that we know are using this and having a lot of success. I know there's a whole bunch of other states out there that have tried it. But is your state using lifts that are more than 5 times that nominal maximum aggregate size? If you do, I would love to hear from you. Feel free to shoot me an email. My email will be later on in the webinar here. And so I'm kind of I'm leading up a little project with the Asphalt Innovate, Enlighten, and Implement, the AIEI, that is part of the Federal Highway Administration's toolbox, if you will. And so I do want to learn. If you've got something going on out there, I want to hear from you. And then I do also want to say, watch the AIEI channels, because we're going to be putting out some training and additional things on thick lip paving through AIEI. Given that, Jay and Kimmy, I want to turn it over to you guys.
So we're going to tell you all a little bit about the history of thick lift paving in South Carolina, some of the keys to success that we've seen, and it's certainly going to be echoing some of what you've heard. And Kimmy's going to get into a little more details on the mix design part of it. So thick lift paving started for us in 2015. We had a road that was kind of falling apart, and we had to get a quick answer together of how to fix this. The contract actually had to be pulled. It was milled, and when traffic got on it, it started falling apart. Contract was canceled on the interstate. That's not something that happens very often. So we had to try to get an answer of how to rebuild this rapidly without making a lot of changes to existing specifications that we had. So we wanted it to be able to hold up under traffic, return to grade each night so we didn't have any drop offs, easy to compact. We didn't want it to rut when we put traffic on it. We didn't want to have to change mixes during the night. We wanted to have one mix that we could build a full structure with. We want everything was kind of centered around getting more production. And we wanted to be able to do work during the winter months and not have any special equipment required. That first project, again in 2015, began right in the end of January, beginning of February. And the first night we did the test strip, it was about 31 degrees. And it worked out pretty good. We didn't have any issues with those colder temperatures. Ultimately, that project was a 10-inch replacement on the outside lanes and 5-inch on the insides. That 5 was done in one lift. The 10 was done in two. It did have a surface and an OGFC on the top for final. 150,000 tons replaced in 7 months. They used 2 different crews to do that. And there was a time incentive. It was an A+B contract, so it moved very quickly. 10 years it's been in service. I rode through it last week and it's still looking pretty good. After that project, I-385 in Greenville was the next interstate project. It was just a year after. We did 14.5 inches removal and replacement in one night on the outside lane of that for about 4 miles. And that was done in 3 lifts. That project turned out pretty well. They made those lifts incrementally shallower as they got to the top to help with the ride a little bit. And there was traffic on that for about 18 months before the final surface got put on it. Next project that came along was a primary route, SC 544. And we replaced 5 inches in one go on that project. And that was done during the winter time. So we decided to diamond grind the surface on that to get a ride. I'll tell you a little more about that project later. After that, the department started getting pretty comfortable with using it, and we started allowing it for full depth patching all around the state. And then we started using it for shoulder widening, in particular in cases where the travel lane is being widened. So if we're going from a 10-foot lane to a 12-foot lane plus a paved shoulder, we started using thick lift paving there. And in that case, it's going down usually in either 400 or 600 pound per square yard lifts. Since that time, it's been used on numerous temporary pavements for MOT on the interstate. Most of those have been around 10 inches. We had one project where we had sub acceptable clearance on bridges on coming across the interstate. And what we did is ended up going down and building a thick lift down and having enough room to where we could mill some of that out and gain a few inches of clearance between the bridge and the surface. That project is not completed yet, but it began in 23. That worked out nicely for the department. Right now, one of the projects that Travis mentioned is a 10-inch replacement on I-26 that has been going on for a couple of years. There have been a number of smaller projects. I just wanted to feature districts 5 and 6, which are coastal areas near Myrtle Beach and Charleston. They've been using it a good bit in high traffic areas where we want to not have drop offs. A lot of those have been in the 5 to 6 inch range. And we've used diamond grinding on a couple of different roads now, but most of them have been covered with a lift of surface. So some of the keys to success that we've seen are, first, understanding what's there, milling and trucking, and how that controls the time of the operation at night. Test strip is very critical. Rolling and compacting is a different kind of material. It's very tender. We have found that confinement of that is very critical. The type of tack and the way we place our lifts on timing impacts how much production we can get in a night sometimes. Ambient temperatures, using warm mix has been very helpful. Achieving ride is critical. And then just the mixture characteristics itself. So going into each one of those a little bit, Understanding what's there. So obviously, we're trying to rebuild a road that is full depth damaged. But we have some roads here in South Carolina that are full depth asphalt, and some that are on base or on cement treated bases in some cases. And we just need to understand how much asphalt do we have, what's there, and what are we going to be placing this thick lift on top of. There are cases where the asphalt itself just needs to be replaced and we can still keep the base. Or in some cases, we're going to be placing it on subgrade. It's just very important to know what you're going to be dealing with. Secondly, what are the limitations of how we're going to run the equipment? And do we have curb and gutter that we need to tie to grade on? Do we have a barrier wall that we need to tie to grade on? Do we have room for dual lane closures? Is a big part that I'll talk about a little more here in a minute. Just understanding what are the features of the road that may restrict the way this operation is run. So milling and trucking are very critical, often dictating the amount of production that you get in a night. The first step is removing it. And if that goes really slow, you have less time to put it back. So a lot of times our contractors are using multiple milling machines. 2 is very common. I've even seen 4 on one job. Usually they're having to make more than one pass in order to get depth, more than one pass in order to get width. So having enough milling machines to get it out quickly makes a big difference in how much you can put back and how far down the road you can go in a given night. One thing that occurred on our second job here that I want to point out is the belt housing cover on this milling machine actually restricted how far we could mill down. And we had to step that milling operation over in order to facilitate just the way the machinery was built. In this case, we actually ended up liking it because it staggered that joint for us. Whenever we can stagger that vertical joint, we prefer to do that. Sometimes we don't have enough room. It's not done every time, but main point here is making sure that you have an understanding of how the milling operation is going to work and having enough trucks to get that material off and then bring material back to keep the paver moving is very critical. Next is avoiding placing trucks in the hole after you've cut it. So on the left here was the 385 project. This was the second one that we did. This project was actually designed to be done under dual lane closures. But one portion of the job, they elected to try to do some work during the day and did it with a single lane closure, which forced them to have to back the trucks up down the cut in order to access the paver. And in doing so, we ended up having some problems with that subgrade. What we would like to see is the pictures on the right where we have a dual lane closure. The top right picture here is the same project, I-385, same lane, just farther down, where we have an MTV transferring the mix into the paver. If we can avoid placing traffic on that cut, we try to do that if at all possible. Test strips, very important, just to make sure that we understand how everything works. Our specification requires a 500-foot test strip for any lift thickness greater than 300 PSY. We try to do that on the shoulder where possible, and in most cases, our dual lane pavements on the interstate shoulders match the main line, so we're still dealing with the same kind of conditions that we would on the main line. It's a good way to get a feeling for the operations. These temperatures vary throughout the project, and sometimes the way that mix reacts varies. The first project we did again started at 31 degrees in the end of January, February, and it ended in 100-degree temperature in July. And they did have to handle it a little bit differently. At one time during that first project, we thought we may need to do two different test strips, but the compaction and everything still ended up looking good. We didn't have to dig into the details quite so much. But what we do is similar to what Travis mentioned, is cut cores on this test strip And then we bisect those cores. Over here on the far right-hand side of the screen, you can see that was the very first test strip that we did. That was 2 5-inch lifts, and we bisected the top and bottom of each lift and ended up getting pretty consistent compaction throughout that. We also checked over on the joint within 2 foot of the edge to make sure that we were getting acceptable compaction there. And then we run nuclear gauge shots to correlate to this. And ultimately, in the end, we use nuclear gauge shots for the whole process for acceptance so that we don't have to wait on coring at the end of the night. And we have a little more time. A lot of times we're pressed to release to traffic at the end of a night's production. I want to show you a quick little video here, rolling and compaction. This material is definitely tender. This video was the test strip at NCAT. I took this video when that S9 section was constructed. So this is an 8-inch lift. I want you to pay attention to how this material moves in front of the roller, both ends of it. We did see a similar amount of roll down, 1/4 inch per inch on this particular and most of what we've done, but this material is very tender. Having it confined is very critical, both to get the compaction, but also to make sure that we end up having the cross slope that we want. I'm going to show you that in a minute. This is another view of the same test section. You can see as how rollers stop. You got a large displacement there, a lot of roll down. If we miss anything on our roller pattern, or if we have rollers stopping and sitting, or if we stop the paver, you're going to know it. As Travis said, all the same best practices apply, but they're even more important on this material. Keep everything moving. This is a picture from I-26 where we did not have confinement. The outside shoulder was widened in order to be a temporary pavement for maintenance of traffic. Picture on the left is removing the pavement. Picture on the right is after paving. That outside edge walked more than a foot to the outside than what we had anticipated. And we ended up being quite steep on the cross slope. This needed 2 to 3 inches in some places of correction on the outside in order to get back to a 2% cross slope. So this performed fine under traffic for about 18 months, more than 50, 60,000 ADT with probably in the range of 15% trucks. It worked fine, but it did require a little extra asphalt to correct that because of the material walking away from the roller. So just be aware. Tack and lift placement. We utilized the 6422 tack between lifts so that they didn't have to wait for it to break. But the problem with that was in any case where we needed to put a truck in there for whatever reason, we couldn't have a dual lane closure. We had tracking issues with that. So 6422 is no longer required. It's allowed by South Carolina specification. Also allow normal hot applied tack. We do definitely encourage using hot applied material on the vertical faces to ensure a good joint is being produced there so that we don't have any water infiltration. Our first projects did not wait for lifts to cool in between, and we didn't see any big issues there. Again, the first projects, the first 2 that we did, everything was about speed, time. And we did not see any issues with it, but now our more recent projects are waiting between those lifts, and it doesn't seem to be a tremendous time factor for us. We do prefer that it's placed during the cooler months. We have seen some excessively tender mixes during the summer. So just be aware of that. We certainly prefer to place it during the winter if possible. We incorporate warm mix, get a better time for compaction window and temperature uniformity. Ride. This is worth mentioning twice here. Best practices apply and they are amplified. I think you've heard it 4 times in this presentation today, and it's 4 times important. One of the biggest issues that we've seen on a recent job was at the beginning of a day's production when they first start pulling off. Sometimes that can be a problem spot. This I-26 project that is ongoing now, they have started milling 3 or 4 inches down into the previous day's lift to start their pull and then coming off of it. And that improved things greatly for them. That has not been done on every project, but that particular contractor is using that to improve their start and stop ride bumps that they were getting. You can get a ride on one lift, but it's pretty difficult. We pretty much count on covering it with either a lift to surface or diamond grinding. And why the diamond grinding? We've seen some improvement in noise. The pre-grind ride on 544 was about 132 inches in the worst spots and as low as 21 in the best spots after grinding. It's about roughly a little more than 50% reduction in IRI. One of the big things for us, though, is it can be done when it's cold. We don't want to put our surface down when it's really cold, but you can diamond grind, and we can do thick lift during the winter months. So the main reason we used it on the first project was it had to be done during this particular time, and we wanted to get the project completed. So we said, well, hey, let's go with diamond grinding. We don't necessarily have an impact with temperature there. And ultimately, it turned out pretty good for us. Quick look at some of the pre and post ride IRI on the 544 project. The pre-ride was up here around the 60s to 80s and most of it. This is just one portion of the job. And then the post ride was 20s and 30s, mostly with a couple in the 40s. Very smooth pavement. It's turned out really good for us, still in service. With that, I'm going to hand it over to Kimmy.
I'm going to go really quickly through the mix design objectives. Travis, Nathan, and Jay at some point has hit on these. But when you're looking at what were the objectives for the mix design, we wanted to place a mix that would hold up under traffic. It needed to be stiff enough so that it could serve as a riding course as well. But we also needed the mix design to be fine enough in gradation that it would seal out water if it was exposed for several months or even until the next construction period. We also wanted to make a mix design that's easier to compact, but it still needed to obtain as much maximum density as possible. And in order to do that, we also going to return it back to heavy traffic the next morning prior to like rush hour. So we needed to make sure we're getting that density. We need to make sure we're doing the things that we need to because we are going to expose it to traffic within hours. So what mix could we use that would be good under traffic, both in strength and durability, but it would be fine enough that it would seal the water out if it is going to be exposed for several months to years? We chose to use an older 12.5 millimeter super paved surface. We now call it our intermediate B. We chose to go with a PG 64-22 versus a modified binder, and we also allow for up to 30% aged binder or wrap because we wanted that stiffness in there. So how do we make the current intermediate B mix more durable and easier to compact? We need to lower our design and field air void targets. We reduced them from 4 to 2.75%. We're going to increase our binder content. We also lowered our gyrations from 100 to 75 gyrations. We still allow wrap because we want to increase that stiffness, right? We want that rutting resistance. And we chose to go with a warm mix aid so that we could have that aid in compaction. Intermediate B mix is typically only placed at 2-inch lifts. So our intermediate B special is going to be placed in a thicker lift. So again, how do we obtain the lowest return to traffic temperature, reduce the chance of premature rutting and pavement damage? we're going to use warm mix technology or a warm mix chemical process to do that. Here in South Carolina, we cap our intermediate B special at 285 and lower. Real quick, this is just a chart. It's in SEM 402 that shows the gradation and our design criteria. You can see down here that it'll tell you our binder limits, gyrations, what binder grade is required. But really the typical thing that you want to see under your type B special is that we're reducing those air voids requirements. From the DOT's side, when this first started, the SCDOT concerns, the DOT did not want to cut full depth cores every night and leave those holes that could not be compacted properly. Another concern was requiring the contractor to stop early enough so that QC could cool the pavement down to cut these cores and then fill those holes prior to opening traffic. Jay went over that with our test section. That's how we kind of limit those concerns, because they're going to do that during the test section. And then from there forward, we will use gauge shots. And then the last concern, Travis talked about it as well as Jay, was concerned with the vertical edges or the joints not getting enough compaction. And with that, that is the end. I know that was a rush on mixed design, but that is the end, and I'll ask Jay to come back.
Great. Yes, let's just cover some of these recommendations really quick. I thought this was an excellent webinar, by the way, to our three presenters. Just some really, really good information. So I want to summarize them. Jay did a great job of highlighting multiple times. The consequences of poor practices are really amplified here, but also following following best practices is amplified. You talked a lot about smoothness. You talked a lot about density, both joint and mat. You talked a lot about paving operations and logistics. And I really like the suggestion to do a trial section, a test section, walk before you run. Even from the tracks perspective, we look at those initial test sections that we did, or trial mixes that we did before we even paved S9 as trial sections. But then honestly, we just keep adding to our knowledge bank to do it better each and every time. Sounds like that's what y'all's contractors are doing as well. However, even with these consequences, the benefits seem to really outweigh the concerns. I mean, you have excellent density, reduced project costs, reduced user costs, more flexibility. You can release the road, open sooner, et cetera. So I like that point. A couple of really short practical ones. Paving at ambient temperatures reduces cooling times. When we did this on the track, I think we deliberately paved in the late morning and let it get really, really, really hot, and it took quite a while. So night paving is a great opportunity to do this. One thing I learned, I never thought about this until Jay brought it up, is that milling can actually be slower than paving, significantly so, and that you can do this with one paver, but you may need multiple milling machines. And I thought that was really, really a great point. Confinement is necessary. It's absolutely critical. Otherwise, you're going to have a bunch of mix walk away from you as it just kind of sloughs out to the side. We've seen that in some of, actually, I can think last year whenever we were actually doing another test section for South Carolina. We were putting a 6-inch section down, and we were paving a trial mix and trying to mess around with density, and it was unconfined, and so it just sort of slumped on those edges. But I thought those were some really practical points. And then to what Kimmy just said, I like how you mentioned not being afraid to use wrap, because you do need that stiffness, but then also using warm mix additives. Specifically, I know y'all use chemical warm mix additives to achieve the workability that you also need. And I thought that was a great way of framing. You really need both, and both wrap and recycled materials and warm mix really achieve that. So I do want to thank Jay and Travis and Kimmy. That was excellent. We do have quite a few questions in the chat. Travis, do you want to go through some of those?
Yes, I looked at some of those. One of the first ones that came up was, about using warm mix additives here. And I know both the states that I highlighted used the warm mix additive. to try to make sure they got compaction. Kimmy, can you speak to why that was so important for you guys there in South Carolina?
Well, I'll let Jay tag if
No problem.
he has anything to add, but it was just important because we knew that in order to return back to traffic, right, the pavement is thicker lift. It's going to take a little bit longer to cool down. So using warm mix will not only give you workability, but also it's going to, you're starting at an already reduced temperature. So that way you can allow traffic in a timely manner.
Okay. Great.
Want to add anything?
Nothing to add. You nailed it, Kimmy.
Okay, cool. Todd Manziel from Caterpillar asked if pneumatic tire rollers were used, and if there was any comparison between that and the other. Jay, did you guys use rubber tire, or was it all steel wheel rollers with the projects that you did?
Don't think I've seen a pneumatic on these. I think we've only
Yeah.
done steel wheel. Again, what we're using is a former 12.5 millimeter surface mix.
Yeah.
And we get it pretty tight with the steel wheels.
On S9, Travis, we used the breakdown was a steel wheel, but we actually did have a lighter pneumatic tire roller, not one of the big ones that you normally are seeing, but that was used as an intermediate roller on S9.
Yeah. And I'm such a huge fan of end result specifications anyway. Let the contractor use whatever they need, whatever is going to work for them, and require the density at the end. That's my my thoughts on that anyway.
And that's an interesting question.
Mhm.
And so, but we didn't do any comparison. And I went back through, like, actually, as one of y'all was presenting, I went back through my pictures, and I remember having a conversation about um, pneumatic tire rollers. But I don't. But most all the breakdown was done with steel wheel.
Yeah, cool. Okay, there's a question here of in Utah, when they dropped the air voids down to 0.75%, did they also reduce the density requirements? And no, they actually raised it. They actually raised that density requirement. So they were targeting 96, and as you could see in some of that data that I was able to show and share with you there, that they were achieving 97% density pretty consistently with their high mod mix there in Utah. Do you guys have in South Carolina? Do you have off off the hip? Do you have any idea what some of your densities were achieving in those projects? I know that's a tough question to ask. I know that most of us don't have that just in our hip pocket.
Go ahead.
Travis, I was going to say off the top of my head, I know everything's been above 92, mostly in 93 to 95 range. And we really have not had an issue with compaction that we've had to, oh no, we got a problem. We got to figure this out. Compaction has not been a problem on these jobs. The biggest thing that we deal with is ride, number one, and getting good pinching of the joints on a few of these jobs has been a little maybe not great.
Okay.
But that's only been on one job that I can think of, but compaction just hasn't been an issue.
See, and I think that's so interesting because we all started in this asphalt industry being told you can't compact it more than 4 inches thick, or more than 3 inches thick, and to see this now and know that so many of you are finding great success with the densities on these thick list pavings is really exciting to me.
And I think
Travis, I'm sorry, Kimmy, go ahead. And I got two short questions.
But I was going to say, is relating to density. A lot of technologies come out, right, since the old ways of doing things. And I think like warm mix has helped tremendously with that as well. So technology is not a bad thing.
Great point.
And that goes to my question, Kimmy. You may have mentioned it in your mix design sheet, but I can't remember. Do you require warm mix on these projects?
Yes.
Okay. Yeah, I think that's really helpful. I have a question about grinding. Have you guys noticed, does adding grinding for smoothness, does it make it less cost effective, or is that or do the contractors kind of go ahead and bid that in, or how does that work?
We have not had any cost associated with grinding that has been prohibitive. I would put it to you that way. We look at it a little bit in terms of the cost of diamond grinding versus the cost of a lift of surfaces. Is the diamond grinding itself is much cheaper.
Mhm.
But it is just from a ton standpoint, we're still putting the same tons down. So you're adding a little bit of cost on the diamond grinding. The biggest thing on the diamond grinding is allowing us to do it during the wintertime, though.
That was a great point.
The first project that we did was in the Myrtle Beach area, and it had to be done before the tourist season kicked back up. And we needed to do it while it was still cold. So that was really what drove us to the diamond grinding. And we've just tried it a couple of times here and there since, in places where we were a little concerned about having drop offs and didn't want to have water, that couldn't get into drainage boxes appropriately, where we had a lot of lane changes going on. So we felt like it was giving us a little bit of a safety benefit.
And so somebody had a question in the chat about the ripples. The ripples that I showed on the track, we ultimately allow diamond grinding. We use diamond grinding for smoothness on the track simply because we got 46 test sections and 46 joints, and otherwise you're just bouncing all the time. So we diamond grind frequently. Is there a bonus, or is smoothness a pay factor, and is there a bonus on it? And then added to that, do you let them diamond grind for smoothness and achieve a bonus? How does that work?
Yes, it is a bonus in our specification as long as we are more than 45 miles an hour on that section, which I think everything we've done has been. And we do allow them to capture that bonus with the diamond grind. And that may have a little bit of an impact on the cost for us, I'm sure.
That's a big, yeah. There's some states that they'll allow diamond grinding, but they won't give the bonus to the paving contractor. So I think that's another example. I think of working well with the industry and recognizing the challenge of getting smoothness, and if they know they can diamond grind, it probably makes it cheaper for you.
I have a quick question for you guys there in South Carolina. You talked about doing a little bit of shoulder widening using this thick lift. Now, we've talked about the confinement. Is this where you were showing that you had to kind of correct with the additional asphalt, or how did you guys find a way to confine that widening section so that you didn't get the mix walking away from you?
Yeah, go ahead.
You want me to do it?
Yeah.
Okay. Two different things, Travis. So the widening that I showed was basically creating a temporary lane on the interstate.
Okay.
And what I'm talking about when I say using it for shoulder widening, usually they're notching that out with a piece of machinery that cuts down and removes their material. So you do have good confinement on what I'm gonna call standard safety shoulder widening on resurfacing projects. So South Carolina DOT has an initiative to place paved shoulders and rumble strips and widen lanes on high volume secondaries and primaries where we have high crash incidents.
Okay.
And there's a special funding set aside to do that. And literally we've been widening a lot of roads over the last 7 or 8 years with that.
Yeah.
Great.
Thank you.
Yeah, well, thank you to all of you guys for this information. So we're going to go ahead and round it out here.
Hey, Nathan.
Yeah.
Can I say one last thing on the diamond grinding that we
Go ahead.
do?
Yeah.
Yeah.
So aesthetically, traditional diamond grinding is done for ride, and it might be hit or miss. So you get a lot of holidays, the spots where the grind texture is not applied. We wrote into our spec that we want almost 100% texture. So that is different. And when a diamond grinding contractor comes in, they need to be aware that it might take them multiple passes to achieve that. But from an aesthetic standpoint, it looks so much better. And So just keep in mind, we do that.
Well, from someone who only grinds for smoothness on the track on thick lift sections where would you call them holidays? But where you're kind of skipping over low spots and then you end up having it look like a Dalmatian out there. I agree. Aesthetically, that's a very wise addition to a specification. As long as I think you should be willing to pay for it. I mean, roads ought to look good, and so that's a great point. Thank you for adding that. All right, Travis, take us home.
All right, that sounds good. You can always get on the NCAT website and at ncat.us and find different research and things that have happened there. We are always on the hunt. Nathan and I really have initiatives together to try to implement as many of these things as we can and help folks do that. So don't hesitate to reach out to us. Training in Your Pocket, free on YouTube, 3 to 5 minutes or so videos that are very informative, but they are also a little bit entertaining. Please utilize that as much as you can. Share it with folks. Any other training that you may want to get into, if we can help you out, don't hesitate to reach out. Given that, our next webinar is November 20th, same time, same place. We're going to talk about longitudinal grooving for asphalt pavements, which is something that's really exciting to me. It's something that Nathan's passionate about because it's part of the work that he's doing out there at the test track. So go ahead and get registered when you see that come out. We'll go from there.